Hello, this is Ms. DB, and today we are going to learn about roots and real numbers. This is from Chapter 1, Section 5, and this video is a little bit longer, and also the assignment will be in 3 parts because we have the first part, which is just a regular worksheet, and then we do a little bit of practice in Sketchpad with plotting real numbers, putting them on a number line, and then we also have just a multiple choice, classify the numbers as real numbers or rational or integers and so on. So our objectives are to evaluate expressions containing square roots, that's what will be on the first worksheet mostly, and then classify numbers within the real number system. So here is some information for us. A number that is multiplied by itself to form a product is a square root of that product. Here's what we're talking about here. If you have 3 and you multiply it by 3 and you get a product, the product would be 9, then when you take the square root of 9, you get 3, which is what we started with. So squares and square roots are inverse operations. They undo each other. This symbol, the square root symbol, is also called a radical, so you may see it called either one. And we have been mostly working with square roots. Now you don't put a 2 in a radical for a square root, you just use the square root symbol. But you will see some different numbers inside that little angle once in a while. So there can be things other than square roots. So, and we'll look at some of those as well. So positive real numbers have 2 square roots. The principal square roots of a number is the positive square root. So when I did the square root of 9, I just took the positive. That's the principal. But what if I took negative 3 and squared it? Negative 3 times negative 3 is also equal to 9. So really, when you take the square root of 9, there's 2 answers, the positive square root of 3 and the negative square root of 3. And you'll see this little symbol here, the plus or minus, written in front of square roots a lot to show that there's really 2 answers when you take the square root of a number, the positive and the negative. Here's another example with 4 and 16 and negative 4 and 16. 4 squared is 16, so the square root of 16 is 4, but negative 4 squared is also 16. So the square root of 16 can also be negative 4. All right, so here's a table. It's got the bottom row has the number, and then they squared it, and then they get to the perfect squared. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. I think they show that table again. Yes. You can also think about it going the other way. If we took the square root of 0, we would get 0. If we took the square root of 1, we would get 1. If we took the square root of 4, we would get 2. So on your worksheet, one of the first things you have to do is complete this table. So obviously you could go back to the video and pause it and see what you should get. But you should have these memorized. So the first table is the squares. So if you take 1 and square it, you'll get 1. And so on. You're going to go all the way across and go all the way up to 13. 13 squared is 169, so you'll write that down here. Now, if there's a missing blank on the top, then you're just going to have to go in order and say, well, that's going to be 5 squared, and then double check that that matches. Yes, 5 squared is 25. So there's a few blanks on the top too, and then the answers for what they are when you square them are already filled in. In the second table, you're going to take the square root of each of the perfect squares. So basically, I'm taking the square root of every number in this row. So the square root of 1 is 1. The square root of 4 is 2, and so on. So there's a couple, again, that you're going to have to figure out. What was this one? How did I get the square root of what equals 3? And you can look up at this table to see what that was going to be. 3 squared is 9, so therefore the square root of 9. Now, for square roots in typing, when you're typing in a Word document, I use SQRT. I just write SQRT. 9 means the square root of 9. There's a symbol here, so if you're doing your worksheet, you can copy, highlight that, do Control-C. You can copy and paste it. I just got that from the Insert menu. That square root symbol does not have the line across the top. So if you have a lot of numbers or expression to put in after the square root symbol, then use parentheses, like if you have pluses or minuses or lots of numbers. If you're printing your worksheet and doing it by hand, of course, you just make a little mountain and then a valley, and the valley goes a little higher, like a cliff, and then you go straight across and your numbers go inside of here. Do not use the division sign for square root, like, you know, the dash, the slash, because it looks like you're dividing instead of square root. There's really no good way on your keyboard to make a square root sign. So like I said, I usually just type this, but also you can copy and paste this symbol or insert it. All right, so here's what I was talking about before, is that radicals are not always square roots. In a square root, we understand that the index is 2. We understand that this is a square root, that we're undoing a power of 2. That's why we call it square root. We're undoing a square. But we can also take cubed roots. We can undo a cube, and then you put a little 3 in here. You can have fourth roots, and then there'll be a little 4 in here. So the fourth root of, let's see, 16, 2 to the fourth is 16, so this is got a little bit messy, but this should say 2 equals the fourth root of 16, because 2 to the fourth equals 16. Now the good thing about these cubed roots and fourth roots is that they're going to be very small numbers because they get big so fast. Like, we can do 3 cubed is 3 times 3 times 3 is 27. So therefore the cubed root of 27 is going to be 3. We can do the fourth root because 3 times 3 times 3 times 3 times 3 is 81. We did that in the last worksheet. So the fourth root of 81 is equal to 3. But after that it gets really big, really fast. So 81 times 3 is already a pretty big number. 243. So you might see the fifth root of 243 equals 3, but really you're not going to see any higher than that because you'd have to get out a calculator to figure it out. So you're going to have fairly low numbers when you deal with cubic roots and fourth roots and fifth roots and so on. So try the smaller numbers and then you'll find the right answer. All right, so here we have 2 square roots. How do I know they're square roots? Because there's nothing inside of here that would indicate it's something else. So then we just assume that it's a square root. So this is just the square root of 81, and that's 9. And we're finding the principal square root is the positive 9. If they ask for both numbers, then it would be plus or minus 9. In B, they want the negative of the root 25. Well, the square root of 25 is just 5, and then they want the negative in front of that. So this would be negative 5. Remember that a square root undoes a power of 2. Now here we go with a cubed root. If we have the cubed root of negative 216, so let's think about that. We want some number to the third power that's equal to negative 216. So let's try some different numbers and see if we can figure it out. Well, 1 cubed is only 1, so that doesn't work. How about 2 cubed? 2 cubed is 2 times 2 times 2 is 8. That's too small. 3 cubed we just looked at was 27, too small. 4 cubed, well, let's try 4. 4 times 4 is 16. 16 times 4, this is going to be 64. That's too small. How about the fifth root? This is 125. I know that one. 5 times 5 times 5 is 125. Let's try the sixth root because we're running out, or not the sixth root, this 6 as a base. So 6 times 6 is 36, and we need one more 6. 6 times 6 is 36. 6 times 3 is 18, 19, 20, 21. 6 cubed is 216. That looks very good, except that we need a negative. Is negative 6 cubed equal to negative 216? Well, let's see. A negative times a negative would be positive 36. And a positive 36 times a negative 6 would be a negative 216. So we figured out that negative 6 is the cubed root of negative 216. Now this is a fraction. This is a square root. You can rewrite this as the square root of 49 over the square root of 9. The square root of 49, that's a perfect square. That's on your table. That's 7. The square root of 9 is a perfect square. That's 3. So the answer to this is going to be 7/3. You can also do it the way they did it. Now here's a cubed root, but we can write this as the cubed root of 8, I know what that is, over the cubed root of 125. Now remember, in a different problem, I was trying to figure out the -216. Look at, here's the 2 cubed is 8, and here's the 125, that was 5 cubed. So if you make a list, keep it to yourself, keep it off to the side, so when you're working on these, you can say, oh wait, I know what 2 cubed is, or what the cubed root of 8 is. The cubed root of 8 is 2, and the cubed root of 125 is 5. So now I figured out that the cubed root of 8 over 125 is 2/5. Here's another example. We're going to take the square root, because there's no other number inside, there's no other indice here, of negative square root of 4 over 25. So you would get the square root of 4 over the square root of 25 and put the negative in front, and you would get square root of 4 is 2, square root of 25 is 5, and that's it, you're done. Here are the problems from your worksheet. You can see that these are all square roots. So the square root of 121, that one you can find in your table, the square root of 256. So you have to find something that's squared that would equal 256, and the number that goes in the box is your answer. So try some different numbers and see what you get. Now number 7, the square root of 1 over 169, you could do the square root of 1 over the square root of 169. Both of these will be on your table, and you just need to find the square root of each of those numbers and write what you get. Same with 8, except in 8, there's a negative in front, so your answer will be negative something. I went out of order here, I guess, but 4 and 6 also have a negative in front, so their answers will be negative whatever it is. 6 is negative 20, I know. Now here we have some roots that are not square roots. We have cubed roots, fourth roots, and that's it. So let's look at number 11 because of all the negatives here. We have negative, the cubed root of negative 27. So the question is, what number to the third power would equal negative 27? So you can try some different numbers. Let's try 2. 2 cubed is 8. Negative 2 cubed is negative 8, so that's obviously not going to work. Now you might recognize this one. We've done this one before. 3 cubed is 27, and negative 3 cubed is a negative 27. So our answer for this part right here is negative 3. But this negative needs to get written down as well. This one is a tricky one. So we have negative 3. Or the opposite is another way of thinking of this negative here is it's going to give us the opposite of whatever follows. So 2 negatives together become a positive. The opposite of negative 3 is a positive, and our answer is going to be 3. Just 3, not negative 3. Okay, if we have lots and lots of numbers, they're not perfect squares, like the square root of 15, the square root of 3, the square root of 20. These are not perfect squares. You can simplify them, or you can estimate, or you can use a calculator to get a decimal approximation. So there's several different methods of working with these. In the future, we're going to use the method of simplifying a root, which is to find an exact answer with like simplest terms. So we wouldn't use a calculator to find that. But if you're just asked to find an estimate, then you can go ahead and use your calculator. So as part of her art project, Shonda will need to make a paper square covered in glitter. Her tube of glitter covers 13 inches squared. Estimate to the nearest tenth the side length of a square. Well, we talked about this before, but a square, the area of a square is found by taking s times s, or s squared. So if we know that s squared is equal to 13, we could take the square root of that in order to find what one side would be equal to. So to estimate the square root of 13, you have to think about what times what equals 13. There's no exact answer here. So like 3 times 3 is 9, that's too small. 4 times 4 is 16, that's too big. So our answer is somewhere between 3 and 4. The side length of the square has to be between 3 and 4 inches. So then you can get a little bit more specific. She's tried 3.5. 3.5 times 3.5 is 12.25. It's close to 13, but it's too low. So now she's going to try 3.6. That's still too low, but look at how close that is to 13. It's really, really close. 3.7 is going to be too big, so she tried 3.65, and even that was too big. So far, her best answer is the 3.6. She went even a little bit farther and said that if 3.6 is too low and 3.65 is too high, then it's in between there. Maybe it's 3.62, maybe it's 3.61, but she just said, all right, we're just going to go with the 3.6. You can also check that by just typing that into a calculator, hitting your square root key, and you should get a number close to that. And close to that is this symbol. It means approximately equal to. It's close to. All right, then the second part of this lesson is on how to classify real numbers, how to sort numbers out and what different names they might have. So when you started counting 1, 2, 3 when you're really little. Those are called the natural numbers. They're also called the counting numbers sometimes. And then when you got a little bit older, you learned about 0. When you put 0 into that list, then now that's called the whole numbers. 0, 1, 2, 3, and so on. So it's the natural numbers plus 0. Then when you got into maybe upper elementary school or your first winter in Minnesota, then you learned about the integers. The integers are the whole numbers and their opposites. So 1, 2, 3, 4 plus -1, -2, -3, -4. So integers include the negatives of the whole numbers. There's also rational numbers. All of these ones that we just looked at are rational numbers. And rational numbers are numbers that can be expressed in the form a over b. You can write it like a fraction. So even a number like 8 can be written like a fraction. You just put a 1 under it. -3 can be written like a fraction. You just put a 1 under it. 5.25 can be written like a fraction. That's the same as 5 1/4, or you could write that as 21 over 4. So if you can write a number as a fraction, then it is a rational number. Rational numbers are either terminating decimals, that means they stop at some point like this one, or look at the number 1/3. When you turn this into a decimal, when you take 1 divided by 3, you get 0.3333. This is a repeating decimal. These 3's just keep going. They're not ever going to stop. That's called a repeating decimal. Oops, here we colored on top of our work here. So this just gives you some more examples of terminating decimals and then of repeating decimals. Another example of repeating decimal is the fraction 2/3, which is 0.66666666. But there's other ones as well, like 1/9. All the ninths are repeating decimals. So there's also something called irrational numbers. So there's rational numbers and there's irrational numbers. Irrational numbers cannot be expressed as a fraction. Here's some examples of rational. If you write them as a decimal, they don't repeat and they don't terminate. Here's a really good example that we use a lot, square root of 2. The square root of 2, if you type that into a calculator, you'll see that the decimal approximation that the decimals they go on forever, but they don't repeat. So it's not terminating and not repeating. Also, another common one is pi. We look at pi often is a common example of an irrational number, 3.14268. You know, it just keeps going on and on and on, never repeats. There's never been an end to it. So here's a visual representation of the numbers. We've only worked with real numbers, and you will only work with real numbers up until Algebra 2. We have two types of real numbers, rational or irrational. The irrational cannot be written like a fraction. They're not terminating decimals. They're not repeating decimals. Our smallest group inside the real numbers is the natural numbers that only include the counting numbers 1, 2, 3, 4, 5. No fractions, no decimals. The whole numbers are the exact same thing as the natural numbers with the number 0 added, so only one more number. The integers are all of the whole numbers with the negatives, with the opposites of those included, so that's a bigger group. And then the rational numbers, of course, include all of these numbers, 1, 2, 3, -1, -2, -3, 0. All of those numbers are part of the rational numbers, and it also includes terminating decimals, repeating decimals, anything that can be written as a fraction. Those are all rational numbers. So for this example, we're going to write all the classifications that apply to each real number. So -32, is it a natural number? 1, 2, 3? No. Is it a whole number? That's 1, 2, 3 plus 0. No. But it is an integer. And it is rational because it can be written as a fraction. So it's rational and it's an integer. Oh, and we can call it a terminating decimal. Any integer can be called a terminating decimal because you can write it as 0.0. Okay, how about negative the square root of 14? Well, if you type that on your calculator, the decimal approximation is a decimal that does not end, does not terminate. It does not repeat. In fact, if you have a square root, if it's not a perfect square, it's going to be an irrational number. So any square root that is not a perfect square is irrational. So on your worksheet, there's just a few problems here on the 1.5 worksheet, and then later you're going to do some other assignments where you classify numbers. But for these ones, what you're going to do is circle the correct answers, and there'll be more than one. Circle it or underline it or highlight it or whatever you want to do. So for 24, let's do a little harder one. Number 14, 1/3 is a real number. These are all going to be real numbers, hint, hint. It's rational because it can be written like a fraction. If it's rational, it can't be irrational. It's not an integer because integers don't include fractions. It's not a whole number, and it's not a natural number. Let's do number 24, or not number 24, but number 13, which is 24. It's real, and it's rational. It can be written like a fraction, 24/1. It's not irrational because they can't be both. It's an integer. It's also a whole number, and it's a natural number. So this one had all the parts except for irrational had to be crossed out. And then you can do these last couple. Okay, so remember that we will be working on this type of assignment for a little bit longer than normal because there's so much information in it. So you might need to come back to this video when you get to the other assignments to review some material. Thank you very much and have a wonderful day.